Hello, this is Ms. Gradincic. I am the 7th and 8th grade math teacher at Syracuse STEM at Blodgett. This video lesson is for 8th graders. 8th graders have been learning about transformations and specifically about translations, rotations, and reflections. I will make PowerPoint slides that go over some definitions and keywords that you need to know for this unit and moving forward. But really quickly, on this screen right now, what you're seeing is a coordinate plane. A coordinate plane has equally spaced vertical lines, lines that go up and down, and equally spaced horizontal lines, or lines that go left to right. On this coordinate plane, you can also see the y-axis, which is essentially a number line that goes up and down. And we also have the x-axis, which is basically like a number line that goes left to right. The place where the x-axis and the y-axis cross, it's called origin. The coordinates of the origin are always 0, 0. Coordinate pairs are essentially a pair of numbers that represent a point, a specific point on a coordinate plane. These coordinate pairs are represented by two numbers inside of parentheses. It is very important that you remember that the first number is always the x-coordinate and the second number is always the y-coordinate. Think of the coordinates as directions for location. So in this problem, what we are looking at is two triangles. Triangle T, or this blue triangle, is our original triangle. We are going to translate or slide and move this original triangle T into a new location, which is represented by this green triangle or triangle U. We're going to translate it. Translate is another word or math word that means to slide or move. When we translate an object on a coordinate plane, or really anywhere, every single point on that object is going to move in the same direction and same distance. So what we have to do here, we have to select all the translations that take triangle T. So we have 4 options here, and there may be more than one correct answer. So option number 1 is we're going to translate or move point -30 to point 12. So the way that we know that this is correct is because we can see that just by looking at the orientation or positioning of the green triangle, we can see that those are two corresponding parts or two corresponding points on that triangle. So that is correct. The first option is correct. Number 2, it says to translate point 21 to point -2, -1. So let's look at this very carefully. Where is our point 21? 21 is a point on a green triangle. And point -2, -1 is a point on the blue triangle. So right away we can see a problem there, because the original question is asking us to look at which translations are going to take triangle T to triangle U. So number 2 is not correct because it's going backwards. It's taking the green triangle down to the blue triangle. All right, so number 2 is not correct. How about number 3? It says translate -4, -3 to 0, -1. So that does appear to be correct, because just by eyeballing it and visualizing this, it does look like this point on the blue triangle is corresponding to this point on the green triangle. And number 4 says translate 1, 2 to 2, 1. So I don't even have 0.12 on the blue triangle. 0.12 is on a green triangle, and 0.21 is also on the green triangle. So that totally doesn't even make sense, because we are trying to translate blue triangle onto the green triangle, and both of these points on number 4 are from the green triangle. So that makes no sense. All right. So now the second thing I want to tell you is, in your workbooks, and I believe that you do have workbooks, try to find this problem, and or even just pause this video and take a tracing paper or just a sheet of paper, put it on top of the screen, and then trace, all right, the blue triangle. And then once you've traced it onto your sheet of paper, try to shift or slide or translate that sheet of paper over across the screen and match it up with the green triangle. What you will find out is that they're exactly the same size and same shape. What that means is that translation, which is what took place in this example, only changes the location of the shape. It does not change its shape, and it doesn't change its size. All right. And lastly, what I want to show you guys is, if you were to take any one of these points on the blue triangle, and if you were to count the distance or measure the distance that it moved or translated in order to get to the green triangle, you will find out that every one of these points translated the same distance. So take, for example, this point, -30. In order for -30 to translate to 0.12, we need to translate it 1, 2, 3, 4 units in the positive x direction and 2 units in the positive y direction. Why am I saying positive x direction? Well, because the middle part, the point where the x and y axis cross each other, this is called the origin, and the coordinates of the origin are 0, 0. So if you remember how number lines look like, for a number line, anything to the right of 0 is positive, and anything left of the 0 is negative. And for the y-axis is essentially the same, except it goes up and down. When we go up, we're going in the positive direction. And if we go down, we're going in a negative direction, because once we cross that 0, 0, the center there, the origin, we're going to get into the negative numbers. All right, so point number 2, -2, -1, is going to move 1, 2, 3, 4 units in the positive x direction and 2 units in the positive y direction. And if you do that for all of the other points, you will see that every single point on the blue triangle is going to move 4 units in the positive x direction and 2 units in the positive y direction. All right, so for homework or for points, what I want you to do is look at this one point on the blue triangle. This is the only point that we actually didn't write the coordinates for. So I want you to determine or find out what those coordinates are on the blue triangle and what the corresponding coordinates are on the green triangle. And then tell me how far or what is the distance that this particular point is going to move in order to get to its corresponding point on the green triangle.